All right, I'm recording, I think. Pretty sure. All right, guys, welcome back to Unit 6. This is the last test we're going to have with Miss Kelly. I think this might be the last test for physics ever. So, there's nothing really to say here. It's a pretty easy test. No one came to the review, so I'm a little sad about y'all, a little disappointed. If y'all fail, it's not on me. Just want that to be known, not on me if y'all fail. I don't think anyone would fail. We're all smart beings. But let's go through this. This first page, annotating. Easy. All right, next page. This, you just got to match it. Super easy. We'll match it. Look at this. Okay, so an open circuit, that goes with a break in a circuit. So C goes to 1. A goes to C. Second one, closed circuit. A closed circuit is I'm just gonna look at my thing. It's this one. E. Electricity can flow through this. That's closed circuit. Circuit diagram. A shorthand way of drawing electrical circuits. B and 3. Voltage. Voltage pushes electricity through a current. So 4 goes to D. 4D. Double D. And little. Did it? No. It's not a good joke. I can tell you guys that. All right, current. Current goes with F, the flow of electricity, because that's what current is. It's like riding the waves, bro. Like you're a surfer. You're with the flow. You're with the current. Resistance is A, slows down the flow of electricity. Which of the following are correct? That is wrong. That is wrong. This is correct. That is wrong. Label the diagram. This is what we call a resistor. Oh God, I can't write. Resistor is this. This is what we call a light bulb or a lamp. You can put either or. Because really lamp, the symbol for lamp is that. But I guess you would put light bulb. Just put light bulb on that. These are wires. These wires. E is battery and B is switch. That's a switch. That's a battery. Match the electrical component with the water component and the diagram symbols. So the valve is the same thing as a switch. And the symbol for switch is D. All right. Now pipes. Pipes are like wires and wires are A. All right. No equivalent is light bulb and light bulb is E. Resist flow is resistor. Resistor is C. Pump acts as the battery and the battery is B. Like that. Y'all see that? Good job. Super easy. Wires allow electricity to flow. The battery pushes electricity through the current. Resistor slows down the flow of electricity. Light bulb. Light bulb is used to create radiant energy. I am pretty sure this is correct. Don't trust me on this. Switch can turn the electricity on and off. All right. Now drawing a circuit. Starting on the left with a battery, a resistor, a light bulb, and a switch. I think I messed up. Oh well. We'll draw it correctly. Make sure it's close circuited. So we have a battery. So we're gonna draw the battery. So plus, minus, upside resistor, resistor. Keep going. Then a light bulb, and light bulb is this. Boop boop. Or you can draw this as a light bulb, and then you keep going to a switch. That's a switch, and then you connect it, and that's how you draw that. Uh, and then that's that. All right, guys, you guys got this. Can I select all this? Boop. Moving on. This is just annotating, easy stuff. Following the qualities, quantities, all that good shit. Oh no, I cursed. Yo, editor, bleep that out. Joke, I don't have an editor. I'm talking to myself. I'm bored. All right, volts. So volts, VT equals this plus this, so that's 12. 12 volts. Resistors are all of them added, so 4 plus 1 is 5 plus 1 is 6. And then since V equals I times R, I equals V over R. Yes. Yes. So that would equal 2 amps. And then the omega lol thing right there. And that's the answer for that. And then find the following quantities. 12 plus 12 is 24 volts. Total is 3 plus 3 is 6 plus 2 is 8. 24 divided by 8 is 3. Don't forget to add your units. And that's that. Label the voltage at the letters. So we have a total of 3 volts. So at A, V at A is 3. V at B is minus 1. Pretty sure. So that would be 2, 1, 0. Let me just check real quick with my paper. I'm just running through this. Yeah, I'm right. So 3 volts, 2 volts, 1 volt, 0 volts. That's how it should look like, since all the time when it's right here should be at 0, no matter what. Pretty sure that's what it says up here. Oh, where does it say that? Here we go. Eventually the voltage is back to 0 at the negative side of the battery, then the battery energizes the electrons again. So yeah. Now moving on this one. So our total volts, 9 plus 3 is 12. 12 volts. Our resistor, 1 plus 2 is 3, plus 1 is 4. Omega lol sign. And then our total amps, so 12 divided by 4 is 3 amps. And now we need V over R1. Y'all are like, what? What is that? So we're going to make our VIR chart real quick. R1, R2, R3, oh god, in total, and then VIR, so V equals I times R. Volts are not the same for everything, but we know 12 total volts is 12. Amps are always the same, so 3, 3, 3, 3. Resistor at 1, resistor 2, and resistor at 1. That total is 4. And so what's 3 times 1? 3. 3 times 2, 6. 3 times 1, 3. And that's how we figure out this chart. So R over R1, V over R1, my bad. V, yeah. So R1, we look, what's the voltage? 3. So 3 volts is that answer. V over R2, boop, boop, 6. Easy. 6 volts is that. And 1 second while I check something. Y'all can take a picture, do whatever. I really don't care. And then yeah, and then that's it. And that's it for those are all the answers for that side. Now we're going to the last part. Select. Boop. 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 All right, next. More annotation, more annotation. This we didn't learn, so you might want to look at this area, fuses and electrons and electrical power. We didn't learn that. This is also really helpful. I feel like this is a really helpful sheet that she took from, that she uses. So we're just gonna zoom in. We're just gonna do multiple. So we're just gonna do this real quick. So a fuse is a device that breaks to protect against excessive current. So that goes together. A circuit breaker protects against high current and can be reset. That's what a circuit breaker is. Wires are where most electrons in the circuit come from. The branch is an independent path in a parallel circuit. Power is the product of voltage and current, since P equals V times I. And then junction is where branches joint or split. So that's that. How many branches does this circuit have? We have 1, 2, 3 branches. So we have 3 branches. Label them. So we have B1, B2, and B3. It also tells us how many we have with that. Yeah, it also tells us, yeah, that's actually kind of funny. How many junctions does it have? 1, 2, 3, 4 has 4 junctions. Circle every junction, easy. 1, 2, 3, 4. Easy cash money. A cash money. Then we'll go over here. We'll go. Yeah. 35 amps of current goes through a 40 amp fuse. What happens? So you have 35 amps going in to a max of 40 amp fuse. What happens? Nothing happens because 35 is less than 40, so nothing happens. The circuit continues. Wow, I suck at writing. Okay, now what happens with boop boop? With the 25 amps going through 15. So you got 25 going through 15. What happens? It's gonna break. It's like going through a bridge. Let's say we have a bridge. All right, and the bridge can hold up to 2,000 pounds. So the bridge can hold 2,000 pounds, right? Anything over 2,000 pounds in a break. So we have a car that goes and it weighs 100 pounds, or not even 100, like 1,000 pounds, it'll be fine. But if we have a truck that weighs 3,000 pounds, the bridge will break and it won't be closed anymore. It'll be open, just like this. So 25 amps going through 15 amps will happen. The circuit will break. So you put the fuse breaks. Fuse. You guys can put fuse breaks. I'm not writing that out. All right. How many amps will a 60 watts? So we got power right here. Light bulb use if your house is 120 volts. So we're looking for amps. So we know P equals V times I. We have power and we have volts. So I'm going to use Miss Kelly's way, even though I don't really like it. So to isolate I, we have to do divide by V on both sides. So 60 over 120 equals 0.5, and that's how many amps there are. Okay, moving on. And we'll go here, then yeah, that's how we'll do it. Okay, so how much power is used by 120 volt using 6 amps? So since we know P equals V times I, this is easy. So 120 times 6, that is 720. So 720 watts is that answer. And then 200 volt circuit has 20 amps flowing through it. So 240 times 20 is what? Come on, guys, that's easy. 4,800 watts. That's how much it is. And that's it. That's that. Time to move on to these areas. Oh my gosh, that's a lot. Okay. Select. Coming at you with the semi-automatic. I'll take that. So our V total is 1.5 and 1.5. So that's 3.0. So 3 is that. V branches are always going to be 3 since it says it up here. Treat each branch has its own circuit. These batteries are in series, so you have them together. Blah blah blah. Also says it. Where does it say it? Just like it's just right there. It's just there. Okay, guys, just trust me. It should say it somewhere. Oh, it doesn't say it somewhere. I thought it did. Oh, here we go. Since wires have no voltage, we know that both branches have the same voltage. All right, there we go. That's where it says. All right, where was I? Oh, where's it? It was like that. All right, so 3-3. So ow, frick. So 3 and 3, and then since we know V equals I times R, which is the main formula we're gonna be using. And we already get our R, so we're just gonna put our R in. Oh, we can't do that. So our I, so 3 equals I times 1, and 3 equals I times 1. So these are gonna be the same. So we know the amps are gonna be 3 amps, 3 amps, and then IT equals both of the amps added together. So 3 plus 3 is 6. And to find RT, and we have IT and VT, we just can you put in the formula. So 3 equals 6 times R, and That's pretty simple. That's 0.5. And then power is I times V, and I times V, we have I right here, which is 6 times 3, which is 18. And that's how many watts that is. She didn't teach that, but it's fairly simple, so I wouldn't be complaining. VT equals 12. Then each branch is 12. We have 12 right here and 12 right here. 12 divided by 6, that is simple, that is 2. 12 divided by 3, that is 4, and 2 plus 4 is 6. 12 divided by 6 is what you call 2. And then 6 times 12 is, I want to say 72 watts. Make sure to put your units. I'm not putting the units. I'm just trying to get the numerical answer. And moving on. Simple like that. We'll stay on this side. So our total is 24 volts. Each branch gets 24. Wow, 24, 24, and 24. So 24 divided by 12 is how much? Come on, guys. Oh, wait, I'm alone. I'm so sad. That's 2. 24 divided by 8, that's 3. And 24 divided by 8 again is also 3. So 2 plus 3 is 5, plus 3 is 8. 24 divided by 8 boop, equals what, guys? Equals 3. So that's how many, that's the total resistance. You can also check your work by doing the 1 over R1 plus 1 over 2, blah, 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 to do that. But this is just simpler since we're just not dividing. We're just doing literally V equals I times R. That's how easy it is. But you can check your work with that if you're unsure. And so we have 8 times 24, which should be around 192 watts. Then we're going to put units like I keep saying. So then we move on. We're on this one. So 3 plus 3 is 6. 6 branches. So 6, 6, 6. 6, 6, 6. If only that was a 9. 69. Got him. Jesus Christ. All right. 6 divided by 4 is 1.5. 6 divided by 6 is 1. And 6 divided by 12 is 0.5. 1.5 plus 1 is 2.5 plus 0.5 is 3. So 6 divided by 3 is 2. And then 3 times 6 is 18. Because P equals I times V. And R equals V over I. That's just same as this, by the way, guys. So that's that. Then we move on to this side. Super easy again. Once more. So 3 plus 3 is 6. 6. So we have 6 and 6. 6 divided by 3 is 2. 6 divided by 6 is 1. 1 plus 2 is 3. So, and then 6 divided by 3 is 2. Because this thing. And then P is 3 times 6, which is 18. And that's that. And the last one. Come on, guys. We're almost there. Final stretch. So 6 plus 6 is 12. So we have 12 here and 12 here. So 12 divided by 12 is 1. I forgot to put 12 right there. It's 1. 12 divided by 4 is 3. 1 plus 3 is 4. 12 divided by 4 is 3. And then 12 times 4 is 48. And that's the review. Super easy. No need to stress about this test. You should look over like the first lesson because I don't think any of that was in this review. But that's really it, like the electrons. But that's simple. And that's the review. Nothing too hard, too bad. Good luck with the test, guys. Got any questions? Don't forget to reach out. Mira's also available to reach out. She is just as smart as anybody. And I don't think there's anything else I need to say. Good luck, guys. This should be our last test of the quarter. So yeah, I love you guys. Bye guys. And you guys take care, all right? Good luck on any SATs, any tests you'll have coming up. And bye guys. Oh shoot, how do I? There we go.